All right, so in this second app, what we're going to do is we are going to actually draw on a surface view. So instead of just drawing on a regular view, we're now going to take this opportunity to draw on a surface view, and so we can see that this is my surface view. I've extended the size of this to fill up the entire parent in both width and height, and he's centered in the parent in both width and height over here. So this entire black space is my custom view, which is going to be a custom surface view. And I've embedded this surface view inside of a fragment, which is embedded inside of a main activity. And I think it's important to see these certain design patterns building up and flowing over here, right? So you have this container, and you have an adapter for the container, and then you take our container and you assign it to have a particular adapter. So in the same sense that fragments get assigned, like the fragment manager gets assigned to the view pager, we're really doing the same thing inside of this custom view deep down, and like 2 layers deeper. We've got a holder, which is going to be the holder for the display. We're going to have the holder is going to be responsible for like putting things in and out of the canvas. We're going to have some listener object which can respond to when this holder is ready for things, and then we're going to add the callbacks over here that say like, hey, is my surface created? When has the surface changed, and when is it destroyed, and so on and so forth. So we can't draw on our canvas until the canvas is actually ready to be drawn upon. And what we saw in the previous app was that the canvas wasn't drawn upon until the surface holder had indicated that the surface was actually created. So this callback, this method, is not called until we're actually ready to draw, which is to say that this point in the queue is the right place to be doing our drawing, right? So when we created our custom view, we defined him inside of, we made some new custom code. We told the fragment, so this is my fragment main, we told the fragment that you're going to contain this custom view. And when that fragment actually called the inflator, that calling the inflator and inflating this XML is what's called the constructor on this class. And so that constructor then triggered this my custom view method to get called right here. So we grabbed the holder, we set the listener, we said, hey, this listener is going to tell us when we're ready to draw on our new custom surface view. And I registered to receive a notification that says it's time to draw. On surface view, we got this message. We arrived in here because it was on time and ready to draw. I logged a message, so let's see what the log cat looked like. I probably want to look at my custom view instead. And let's just clean out some of this information over here. I'm going to redeploy so we can kind of watch this happen in real time. The app is starting up, and we got the message surface created and ready. Inside of here, I created a new paint, and this is going to look familiar from custom views. So the paint is going to be the method that's used for, or the paint is the object that's used for like generating the color, setting the color, and setting, you know, the typeface and so on and so forth. So I defined my object. I grabbed a canvas. I locked the canvas, which is to say I grabbed this entire canvas, this entire black space right here. I grabbed him, and through this method, I used the holder, right? So this holder, so there's a reason why we wanted to make this holder over here, because the holder has the thing that it has the ability to interact with this canvas. And so by locking the canvas, we grabbed it, and I can draw circles inside of this canvas. And then when I'm done drawing whatever it is I'm going to be drawing, I unlock the canvas, I release it to go, and then I post my new information on top of here. So I only do this once. I grab the canvas once, lock it, draw, and release. And so you can almost think of it, because you guys know I love clipboard so much, you can almost think of it as like you passing me a sheet of paper on a clipboard. You pass it to me, it's locked, you cannot see it while I'm drawing on it, and then I give it back. I give this sheet of paper on this clipboard back to you. You can't see what's on the paper as long as I have it, as long as I'm drawing on it. So we don't want this draw operation to take too long. And what we're going to want to really do over here is control the timing and the sequence and the flow of all of these mechanisms. Now, lock canvas works on software. It does a software lock. There is an ability to do a hardware lock on this as well, so I can use the holder over here. So I could say, like, let's just comment this out momentarily. I could say C is equal to mHolder.getSurface.lock hardware canvas. And so what this will do is this will grab, this will perform a hardware lock, which is a little bit faster. And then I can do my surface drawing over here as per usual. And then what I'm going to want to do is I'm going to do my mHolder dot unlock hardware. I can't remember the name of this. I think it's actually just unlock canvas and post. Yeah, I think it's the same one. I have to check my notes on these things. And obviously it was not. Let me put this on pause for a second and we'll figure out what it is. Okay, we're back. So I'm in the Surface ref over here. I just kind of remembered as soon as I saw this that the problem that I just did over here was that I used the surface. I used mHolder's surface to lock the hardware canvas in post, but over here I used mHolder to unlock hardware in post. My intuition says that if I use the getSurface.unlock hardware canvas and unlock canvas in post, that this is going to allow us to see our little green circle over here, and yeah, that's true. So this does a hardware, this will be a little bit of a faster operation as opposed to just using the lock canvas in post. But the on surface created is where we can begin to draw, and next thing we're going to look at is figuring out some of the timing of this actual drawing.